All right, so today's study group is topic 3, data analysis in base Python. The main thing I want to focus on today is a little bit more about Lambda functions and like the specific ways in which we use this for data science processes. I know Lambda functions is one of like the harder to understand elements in Python. So I'm going to go through some very specific examples in which we will use Lambda functions. I'm going to show some pretty neat tricks for doing like list and dictionary comprehension. More on that later. And then talk about nested dictionaries. I actually have a mini exercise here for those of you who want to try this. We can definitely talk about this at one-on-ones. And then I'll go into JSON schemas and how we will use JSONs going forward. Before going into all of that, I wanted to note that I've actually added a bunch of resources into this Flatiron resources folder, which you can access from your homeroom from resources Google Drive. There's just a lot here. What's most relevant to you is in this phase 1 folder. This is what we talked about yesterday. I also have like phase 2, 3, 4, 5. There's stuff in there if you're just, I don't know, curious to like read things, but we will hit all of these at some point. All right, so to begin, let's talk about Lambda functions. This snippet of code here actually comes from the appendix of phase 1. So there is an appendix. These are not necessary to go through. This is really for if you want like extra practice. A lot of them are like mini projects, and also some of these are just like more, they're labs that go over things that are less used for our data science purposes, but they're here for you to, if you want more work to do. So this snippet of code actually comes from analyzing Macbeth with Pandas. This snippet of code that I'm going to walk through is from the solutions, and also just walks through the process of counting words in Macbeth. And I want to talk about this because it does make use of lambdas. So for some context, what this is used for, we're getting the whole text of Macbeth, the Shakespeare play. And the whole context behind this analysis is we just want to find the most common words used in Macbeth. So that's the purpose of this analysis. That's the purpose of this code. I want to talk about this because they use a lambda here. And they use lambda here for sorting. Another thing I wanted to mention that we haven't really talked about yet is they use this .get function. So I'm going to talk about some of that as well. But what this analysis has you do, if we take a look at Macbeth, the variable, as you can see here, Macbeth is here equal to request.get blah, blah, blah. This is Macbeth. We will talk more about the requests library and what this is doing in topics, I want to say topics 9 and 10. So yeah, we'll be talking more about requests in topics 9 and 10, but just for right now, good to know that the requests.get just gives you the entire text of Macbeth. As you can see, super, super messy. We do Macbeth.split to just split it nicely. So let's see, words. You can see words now. We've split up every word in Macbeth into a giant list of individual words. And then we're going to do a word count. What we're doing is at this stage, because we want to find the most common words used in Macbeth, we're creating a dictionary that eventually will give us something that looks like this. Word counts, word counts. Eventually, it gets us a dictionary that looks like this. For the word project, 23 times. For the word a, 29 times. Something else, this, and in, 190 times. So this is what this code does. For word in words, and remember words was an entire list of every single word as an element in a list. We're creating this dictionary, we're updating this dictionary by iterating through the list words, and we're using this .get method. So this .get method is really, really interesting. It's actually something that I've been using more and more only very recently. So Python get. Python get's really interesting. As you can see here, the way that you use get, you run it on some dictionary, .get a key name, comma, value. So what are these parameters? Key name is required, is the key name of the item you want to return the value from. Value is optional, a value to return if the specified key does not exist. Default value is none. So let's try it on like a smaller dictionary first. Let's actually copy over this dictionary. This one is actually the one that we used yesterday, I believe. So let's just say we have this car dictionary. If we want to do car.get brand, it returns us Ford. If we do model year, it'll return us those keys. What if we ask for a key that it doesn't have? Color. It returns us nothing. However, if we add this second argument of value, which basically says that a value to return if the specified key does not exist, let's just say we want to return key doesn't exist. Oops. But whenever you see this issue, if you want to put an apostrophe, you can just change it to double quotes. Okay, there we go. And so when we do car.get color, it'll say key doesn't exist. Maybe you want something else like make, key doesn't exist. So this is helpful in this context, and we'll see why. .get, again, pretty useful built-in method. All right, so what we're doing here is for word and words, and let's take a look at words again. Let's just look at the first, like, I don't know, 10. Okay, messy words, but not relevant right now. For word and words, we're going to do word count word counts index word. Remember, this is how we add or update something in an existing dictionary. So let's say the first one is this, I don't know, UFEFF. So it's going to do in word counts, create this UFEFF equals to word counts.get word comma 0. So basically what this is saying, if the word exists in word count, we're going to return the existing count plus 1. If it doesn't already exist, we're just going to return 0 plus 1, which makes sense. Because if it's the first time you're seeing a word, we're just going to create a new key, start it at 0, and just add 1. So this is how you increment the count of words in this dictionary, which is a pretty neat function. It's honestly like a very, very underrated Python method in my opinion. So that's what .get is doing. If you feel like you have the opportunity to use .get, I welcome you to use it. Cool. So in this code, which is provided by the solutions, you can convert this into a list. Remember .items from yesterday. If word counts looks like this, dictionary of, key : word count. Counts is a list of tuples. Very nice. So now we have a tuple of a bunch of words that will bring us from that. Yeah, we'll just tell you, okay, this is the word, this is how many times it's appeared in Macbeth. The whole idea here for this analysis, we want to find the top 25 words that are used in Macbeth. So to do that, the easiest way to go about that is just sort, right? The ideal is to, okay, maybe we can sort this list of tuples such that it's sorted by, the word count. Several ways to do this, but the way that is in the solutions that I do want to point out makes use of a lambda. So let's just take a look at the sorted function and how it works. Sorted Python. There we go. Cool. So the way that sorted works, it works like this. You have to feed it in an iterable, the thing to sort. Is it a list, a dictionary, a tuple, etc.? What is the key? A function to execute to decide the order. And then also whether we want it reversed. True will sort descending, default is false. All right, so several things that we know. If we want to get like the top 25, we know we want reverse equals to true, because if we don't do reverse equals to true, it will give us the bottom 25 words. So actually, let me run this so we can see what the output is. Top 25, run this real quick. Cool, so this is our result. Starts with 620, ends with that at 80. So these are the top 25 most common words in Macbeth. So what we're sorting, the iterable thing that we're sorting is counts, this list of tuples. Reverse is true, we know that. The only tricky part is this lambda. So the way this lambda works in this instance is it works as the key. It tells you how do you want to sort this list of tuples. So in this lambda statement, what's happening is whenever you have a lambda, you have to give it a like temporary variable. It's sort of like, when you do like for I in list, it's sort of like the I. So it doesn't really matter what letter you use here or what variable name you use here. Lambda x. So every x is going to point to every tuple. Each x is going to point to an element in the iterable object that you are passing in. So each x refers to each tuple. And this x index 1 is really just telling it to look at the index 1 element of each tuple. So that's how we get to this top 25. If we give it like x0, or I think if we give it, I wonder if this will work. Cool, yeah. If we give it just regular x, it's going to sort by the word descending. So
would it be possible, sorry, would it be possible for you to write out that, would it be possible for you to write out that lambda function quickly as like a regular for function, just so we can see what it would look like as a normal function?
In this instance, not really, because this lambda works as a pointer. So it's not really a function. This lambda at this moment works as a pointer. There are a couple lambda examples I want to talk through later that then I can show you all as a function. But for this specific example, when lambda is being used as a key, it's only pointing to something. So you can't really turn that into a function, unfortunately.
Gotcha.
Or actually,
like the way you were talking about it, right? Like for x and for x and.
Yeah, I wonder if this will work. Sort function tuple. Actually should not use tuple. Tuple return. I wonder if this will work. Let me just try this. We do sorted lambda x sort x. I think this is how, but this will also pretty much give you the same thing. You still have the lambda there. Let me see if you can do this. I'm just curious. Cool. Okay. Yeah. So this also works. If you have a function that
Right. It's really simple. Okay, I get it. Oh,
yeah.
Oh, gotcha.
Sweet. Yeah, I'm proud of myself for doing that on the spot, actually.
So lambda as a key is basically just a placeholder for the entire tuple. And then you define it like it's just a generic variable that you're using that you're going to define in some other way.
Yeah, so in this scenario, so usually when you use a function, you have to give it the arguments, right? In this scenario, for some, not all functions work this way, I will tell you first. But in this scenario, it recognized that sort function, this function that I've defined, sort function, recognizes that this will work on every element in this list. So therefore, I was able to just be like, okay, just sort func, and it'll apply it to every element.
Because the sorted command is looking for a key. And so the key has to be some sort of function. So by passing lambda, it saves you from having to write out an actual function. So you use the lambda as a placeholder variable to call the tuple, because that's what a key would do. The key equals would do. And then you define which exact variable within the tuple you want to call with x bracket 1 or 0.
Yeah, that's right.
Okay.
Perfect. Awesome. Yeah, I will say lambdas is one of the more like abstract things in Python. So there are usually alternate ways to do lambdas, but it is on it. After you get used to using lambdas, it will make your life a little bit easier.
It's a code saver, basically, so you have to write out less stuff.
Absolutely, absolutely. In Python, I can't really speak to Python because this is what I've known in Python, but I know in like other languages, like I think Java uses lambda functions as well. Someone please correct me if I'm wrong, but I believe that in Java, lambda functions are very, very helpful. And then there's this whole realm of like dynamic programming, which is something I have like almost zero experience in. They use a lot of lambda functions because it saves you from having to define a lot of functions as you need them.
Because like in the case of the command, it already has a set function with key on how it works. So
Mhm.
rather than having to write out a defined function ahead of time, you can just use the placeholder and then define the second part of it, the
Exactly.
individual part, and just break down what key is actually calling. So as long as you understand the command and what it's asking, you can just pass a lambda as a generic and then define it later.
That's right.
Okay.
Sweet. Awesome. All right. So that is just the use of lambdas in a sorting key. I wanted to talk about using lambdas like with maps and filters, kind of similar. I would say that filter lambdas is probably the most common thing I use lambdas for, I think. So I'm going to show you some really, really quick examples. Let's just say we have this list L of like 1, 2, 3, 4, 5, 6. Two functions, map and filter. Basically what they do is they broadcast lambda across all elements in the list. So let me just make a new, here we go. So let me just output what this is. Cool. So what this is doing is it has added 2 to every element in the list. Let me break this down. Map takes in 2 arguments, a function, therefore we have our lambda, and also the iterable, so the list, what we want to map over. Map lambda x on x plus 2 basically says, okay, for every element in L, just do x plus 2. It's equivalent to doing something like this. For x in L, new.append x plus 2, return new. Exactly the same. It's in one line. So why we have to wrap it in list, if anyone has tried this, map actually comes out as an object. So therefore, just because it's in an object, we got to coerce it into a list. So that can be useful if you want to do the same thing to every element in a list. Doing a map lambda, very, very useful. Something that's kind of similar but slightly different is filtering. This is actually the instance where I think I use lambdas the most. Instead of giving it like a function like this, you give it a condition. So here, let's just say that we want only the even numbers. Remember, we talked about modulo on Wednesday. Whenever you do like modulo 2, you're just looking for even numbers. So what filter lambda does is it takes this condition and maps that condition over every element in the list, and then you only return those. So if we run this real quick, we only get 2, 4, 6. Very, very similar to map. Filter takes in 2 arguments, the condition or the function, and the iterable. And similar to map, it will give you this object, therefore we want to coerce it into a list.
Okay, so much like the last example that you used, that's just knowing what the map function itself does and the 2 segments within it. And then again, you're passing lambda as a generic.
That's right.
As a generic, and then defining what exactly you want rather than having to write out a loop.
Absolutely. That's right. Awesome. Okay. So we've done that. Lambda is very, very useful. I also want to point out this other thing called list comprehension or dictionary comprehension. It's a very Pythonic thing. It's, I think, I don't know what other languages have this kind of functionality, but it's something that's very Pythonic, has made things like it's simplified even doing something like this. So if you ever need to make a list from another list, and again, we're using this very, very simple example, we're just going to recreate this in one line. So let me just run this to see what the result is. Exactly the same, but this is known as list comprehension. If you know that you want to iterate through L and do the same thing for every element, you can do this. So what's happening here is we are actually putting a for loop inside the list definition. And we're just saying, okay, for every x and L, just do x plus 2. It actually reads very much like English. We're doing x plus 2 for every x and L. For list comprehension, extremely powerful. I will say in terms of computational power and speed, exactly the same as all these methods. Speed-wise, this is the same speed. doing something like this is the same speed. In terms of memory wise, also the same. So really doesn't matter which one you use. I would say this is the most Pythonic way of creating a new list from lists, in case anyone is curious. Took me a little bit of practice to get used to like writing a for loop within a list. But I think it's something that's really, really helpful. Is sometimes I think it makes your code look neater. So if you've ever in this scenario where you need to make a list out of another list, you can do that. Something else is pretty neat. You can actually do the same thing for dictionaries. So this is known as list comprehension. You can also do something called dictionary comprehension. So instead of, it being in square brackets, you just wrap it in curly brackets, and you can define like keys and values like that. So for example, for X and L, this is a poor like example, but it proves the point that you can do dictionary comprehension. I'm doing X colon X plus 1 for every X and L. So for every X, I'm going to do like, okay, 1 colon 2, 2 colon 3, 3 colon 4. We have 6 elements just like that. If you want to make it even more complicated, we can do like a list of tuples where it's like 1, 1, 2, 2, 2, 3, 3. So let's say we have, let's just call this L2. I'm bad with variable names, but let's just say this is L2. We can do a dictionary comprehension as well. Well, okay, fine. You can actually technically do this. Dict L2 does the same thing. If you have something a little bit more complicated, you can do something like, let's just say we want to take that times 10. So yeah, that's a cool example. So let's just do, let's see, KV. So for K comma V in L2, and again, KV works because it unpacks these. Let's just say I want to do K plus times 2 colon V times 2. Hopefully this works. Cool, awesome, it does. So therefore what I did was I did some function on the K, some little function on the V to create 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So this is slightly more complicated, but just to show, like if you ever needed to create like a new list or a new dictionary out of something that already exists, you can do it in one liner like this. I will say in Python, you got to balance number of lines with readability. So maybe something like this, you could argue that, okay, it's getting a little bit hard to read what's going on. So maybe consider that when you're thinking, okay, I want to make it into like a one-liner versus like 3 different lines. Do consider that as well. But it's a neat trick to show that really takes advantage of Python's functionality. One last thing to add on to this, you can also add conditions. So it can kind of filter as well. So what I'm doing here, X plus 2 for X and L, which is exactly the same as what I had here, 3, 4, 5, 6, 7, 8. Here I'm adding an if statement to act as a filter if X modulo 2 is 0. So that's the syntax if you just want to like add a filter to the list comprehension. So pretty neat. It does both like a map and a filter, I guess. So yeah, just in case y'all are curious, I do think that this is something that is really worth taking advantage of in Python. Sweet. Before I move on to like JSONs and dictionaries, any questions? Sweet. Well, feel free to try this out. No pressure, of course. This is like, you can pretty much do this in, I don't know, regular coding ways. Okay, so I want to talk a bit about nested dictionaries before we get into working with JSON files in a little bit. I'm going to start with a slightly smaller dictionary. This one should look familiar because it comes from your pre-work, I think. Yeah, it should come from pre-work. And this is an example of a nested dictionary where basically the value of a dictionary key is another dictionary or dictionaries within a list or something like that, basically nested structures. Nested structures are extremely, extremely common, especially when you're getting data from API sources, which is something we're going to talk about not next week, but the week after. So this is our example. It's a soccer match list of dictionaries where you have 2 dictionaries, a home and away. Each one has all sorts of attributes and we have players. I wanted to use this example to just show that when you are given a kind of big data source here, it's absolutely okay to like spend one cell or a few cells just exploring it. Some very common things I like to do: check for the type, check for the length, especially if it's a list, and then maybe print some of the elements here and there. So as an example, this entire soccer match variable happens to be a list. Cool. I want to print the length of it to see how many elements are in that list. There are 2. And the first element looks like this. Cool. So it looks like we have 2 dictionaries within a list, hopefully if it's consistent. After this, maybe what I'll do, in addition to that, maybe I'll look at the keys of that first dictionary. Maybe I don't need to have this line now, but yeah. So cool, we have these keys. And then as you're exploring your data type and your data structure, you'll get a better sense of how you want to work with it in the future. So no shame in like spending a bunch of lines just exploring what you're given. That's going to be very, very important once you get to bigger and bigger pieces of data, right? Like I think so far we've really only been working with like data that we can see in a single cell, but it's going to get a lot bigger than this. I think by the end of, I think by the phase 1 project, you'll be working with like a couple like thousands of rows of data. So get used to exploring your data. Next week, I'm going to talk through some Pandas functions to do that as well. All right. This is an optional exercise. Some people want to have more guidance in their 101s. And so if you want me to just check out how you're writing your functions, feel free to tackle these questions. They're not super easy. More than happy to walk through how you code in your 101s. It's helpful for me to gauge as well how you think through your code. So if you're up for the challenge, here are 2 questions for you to answer using this soccer match dictionary. First, write a function that counts how many players have even shirt numbers. And also, second question, write a function that appends player names and shirt numbers to a list until the sum reaches 100. So these are just 2 questions. Feel free to tackle if you want, optional, but yeah. I've also thrown in some hints here. I'm not going to go through them right now, but if you have this notebook and you want to do it, take those hints. All right, so we've talked about very briefly about nested dictionaries and how common they are. Let's do an example. So JSON is another data type that is going to be pretty common. You're going to see a lot of JSON data types when you're working with APIs, and we're going to do that in week 3. Whenever you want to gather your own data, a lot of times it does come in a JSON format. If you have a JSON data, a piece of JSON data that comes from a source, and this example, I'm actually taking data from New York Times. New York Times actually makes their data publicly available through their API. I'm actually going to walk through how you use that in week 3. But usually when you have a big data source, they'll show you some sort of schema. And a schema basically will map out how the data is going to be structured so that people working with it, is a little easier. They don't have to do too much in-depth exploration on their own. So this is an example from New York Times, their API. I believe that this is for their, you can actually get a bunch of New York Times headlines out of their API. I think you can just like search through like whatever dates you want, and you can actually get information on their articles, on the published articles, I think from their archive or something like that. So on the New York Times API, they give you this schema where you can see, okay, well, let's zoom in and take a look. You have like a web URL, cool. Lead paragraph, abstract, headline, keywords, publication date, blah, blah, blah. And with these different indents, it sort of shows you like how nested this dictionary is. So this dictionary has like 1, 2, 3, 4 layers. So as you're working through it, don't forget to use your .items to loop through it. Don't forget that you can do your for KV and dictionary.items to loop through that list. But we're going to do a fairly simple example for today. In the repo, I've actually saved the response into a JSON file. So sometimes you can directly download a JSON file to your computer and you can open it up in your Jupyter notebook. And this is the syntax to use it, to open it. So how it works is you have this open object. This is an open object where it takes in the file name and whether you're reading or you're writing. So in this case, we're reading. So therefore it's an R for read. And then we load the JSON. So we are using the JSON library. We're loading the JSON. This is F. F comes from here. So cool. Now in data, we have our dictionary with these keys. So in exploring this, most of the time, your data will come in something like, well, status is obviously not it. Copyright is probably not it. We can guess that it comes in response. So let's just look at response. And of course, the reason why I can say this so quickly is because I've had experience with this file, but absolutely okay for you to like spend more time exploring the data. So cool. Within response, it looks like we have all this data. And just scrolling up and down, we can see that we have some web URLs. Looks like we have, oh, cool, a headline here, all sorts of stuff that we want to use and maybe get into a cleaner format. So in response, let's just see what keys belong in response. Cool, docs and meta. Meta stands for metadata, so I know that everything is in docs. Sweet. Just by the start here, I can see that docs is a list. So let's just see how long this list is. Cool, 9, not bad for now. So I can guess that maybe we have 9 instances of maybe news articles. So let's just look at the first one. Cool, it fits on one screen, that's perfect. We can see we have web URL, snippet abstract, we have the headline, which is great. Some keywords, publication date, wow, 1904, cool. But yeah, we have sort of like got into the part of the data structure that we have the information that we want to use. So let's try and see if we can get these headlines. So it looks like the headline is under the key headline. And I think I already did this. Oh, right. If we look at the keys, we have all these keys and headline is one of them. So let's just assign docs to this here. So docs is a list with length 9. And let's just print the headline for every document. So for doc and docs, we're just printing headline. Not as clean as we like yet, but at least we can see that each headline is another dictionary. Great, another nest. So what we want, I guess, comes from main. So from doc and docs, instead of just printing headline, we're going to print main. Run that. By the way, this just means new line. If I didn't have this, they would just print one after another. This can sometimes just, make things look nicer when you're printing them. So cool. We have 9 headlines from New York Times from, I guess, the 1900s. Sweet. By the way, in 2 weeks, we're going to work with a lot more data than this. So if you think that 9 is not enough, not to worry. Sweet. So through this exercise, we've basically gotten this very, very messy JSON. If we actually want to look at what data looks like, it's this gigantic JSON dictionary. And we've sort of figured out where the information is that we want to use. And we've gotten to that information in a fairly clean way. So nice. We're going to talk about pandas next week. At the beginning of next week, Tuesday, Wednesday, we're going to spend 2 sessions talking about pandas. Pandas is a library that we're going to be using very, very often. And so I'm going to quickly introduce it today. Basically, what pandas does is pandas gives you the data type of data frames. So data frames actually look like this. As you can see, it's this pretty nice like interactive element here. And we'll be using a lot of data frames throughout this entire course. But I'm going to quickly introduce it now. We'll go much more into detail about what data frames are next week. What data frames or how we can work with data frames between like JSON and data frames is, if you have a list of dictionaries, it will automatically format into a data frame where each key will become a column header, which is pretty neat. So as you can see here, these column names, web URL, snippet, abstract, print page, these are the same as these dictionary keys. Because we know that docs here, which is data response docs, is a list of dictionaries, we can try our hand at turning that into a data frame. So the way that you do that is you use pandas. This is just the way you import it. I'll get more into that on Tuesday. But to turn something to a data frame, you just have to do pd.dataframe and feed it in that list of dictionaries. I can feed it in this. I can also feed it in docs, same thing. One downside is that the headline, if you take a look, if we remember, the headline was nested in a dictionary here. So again, this is on Tuesday, Wednesday. I'm going to walk through some code in more detail. But when you have JSON file format, sometimes it's hard to get it into a table format because of all of this nesting, especially if the nesting is inconsistent. But anyways, this is some code that helps us unnest it. Let me just output this real quick so that we can take a look. So we have our headline here, but if we scroll over to the right, there's some code that unnests the headline. So whereas before we had like the last column being news desk, we look back here, the last column was news desk. This code unnests the dictionary. So basically what this code has done, it's taken the information within this headline here, and each sub key in this data frame, in this dictionary here, is a new column in the data frame. So this is the code to do it. There are, of course, different ways to go about this, but I'll just talk through this fairly briefly. First, we're going to keep track of some new columns. For key and keys, and by the way, keys is going to be the keys of this nested dictionary. So therefore, it's the keys of the headline here. This is one way to do it. Another way you can do it is you can actually pick out, it came from doc headline. Yeah, it came from doc headline. So if we do, let's see. Yeah, if we do docs 0 and then headline. Okay, let me just copy and paste this over so that we can see an example that doesn't use a pandas function. Docs 0 and then headline. And then doc keys. This is equivalent to this. So from that, we can just grab the new keys. For key and keys, we're going to make a new column. Just so that we know it comes from the headline, I'm just going to name every column headline underscore whatever the key was. So therefore, you can see that these new headlines are all headline underscore main, headline underscore kicker. Basically, this preceded by a headline underscore. What we're doing is we're creating this new column. This is something that I'm going to talk about on Wednesday. So don't worry about this now, but this basically creates the new column and you're appending a new column. And then we have this data frame here. So this exercise of unnesting dictionaries, I will talk through how you can do functions on data frames over the next 2 study groups. So don't worry about that for now. Just know that when you have nested data structures and you want to turn them into data frames, you have to do some work to unnest it. But yeah.
So the F string commit, the F string that you have there is so that you output the word headline in front of key, correct?
That is correct.
Okay.
Cool. Anything else? Sweet. Well, the last thing I want to talk about is at the very beginning of this, we talked about how you can open a JSON file. Basically, if you have any dictionary, you can save it as a JSON file. And this is the code to do that. So the way that this works is first, instead of, open the file with a read, we're writing a new file. So whatever you want your file name to be, feed it that. You can give it .json. W for write. As F, I'm going to json.dump my soccer match dictionary. So actually, if we look here, I don't have a soccer match dictionary. I only have this. This is all my folders on my desktop. This is a New York Times response.json. I'm going to do a json.dump of my soccer match. And with that, you can see seconds ago, it created a soccer.json. I can even click into it and look, my soccer match is now saved. So if you have anything that's like a dictionary-like format, you can actually save that to your computer. Maybe you want to use it in a different notebook. For your project, you might be using multiple notebooks, so you can definitely do that. So that's just the code to save any sort of dictionary or list-like object as a JSON. Cool. Well, that is all I had to share for today. Does anyone have any questions? Going once, going twice. Awesome.